All right, so from Wednesday, this was the problem that we were working on. Now, this is on 2.1. I did go ahead and assign 2.1, and that is due tonight, so don't forget about that. So we've got our equation in there. We did table start at 0, change of table was 5, and then this is our output, and we had done that in part A. So in part C, terminal velocity is asking for the limiting value. So the limiting value then is your output or your function. And so if you just continue clicking down, it eventually hits 176, and then we'll repeat over and over and over and over again. So that's where this value comes from. Okay. Then in part D, it says, how long does it take the skydiver to reach 99% of that value? So I took 99% of 176, which means multiply it. So we're looking for 174.24 over here in the output. Now, here's what you've got to remember about your calculator. If I start going up again, it will only go, it won't scroll back up. So I'm going to have to go back in and do a table set. And so let's see, we've gone to 20. So I'll start at 20 now and look at every fifth one. And so then I'm going to go back to table. Yeah. It was down the hallway.
Communication. Failure.
Huh?
That alarm. Communication failure.
Oh, is that what the message was? Which then,
They've been working on this alarm in here for 2 weeks.
so can you guys reset it or just? I mean, I'm fine. I closed the door, but I just thought if there was an alarm going off, y'all would want to know.
Yeah.
So,
But they usually call me from there for about that.
oh,
So this is in the system, it's a communication system, it means it's the wiring.
okay. So when it beeps,
Do
do I go ahead and call maintenance like
Yeah.
it did?
Yeah.
Okay, okay.
They call me.
Call you next time?
Uh-huh.
Okay, perfect. I'll do that. Thanks.
Okay.
Appreciate you stopping by. Okay, so we're looking for 174.24. So I come over here and I see 174.12 and 175.24. So I know it's between 25 and 30. So what I would do is go back to table start and start at 25, and I'm going to narrow my search. So I'm going to do a change in table of 0.1. And then I can go back to table and I'm looking for 174.24. I don't get to it exactly, but it's 1/100th from 174.25. So that's why I said 174.25 is at 25.4. So I said approximately 25.4 seconds. So that's where that came from. Okay. All right. So again, that completes 2.1. That assignment is due tonight. All right. So your calculator cheat sheet. What we've been doing in 2.1 is creating tables. So this comes from section 2.1. All right. So today, what we're going to start learning to do is how to create graphs. So this is what we're going to do in section 2.2. And these are in your notes as well. But you have this cheat sheet if you want to use that. All right. So what we're looking at in 2.2 first are the steps we take to create our graphs. Okay, so before we get to this example, I'm just going to give you a random equation. So y equals negative 0.25 x squared plus 5x. And what we're gonna do is we're gonna look at that now instead of a table. We're gonna look at it on a graph. All right, so we have two letters. We have y and we have x. Y is my what? Function or variable? Function, and does the function go on the vertical or horizontal axis? So this is your y, which is your function. Which means this is your x and that is your variable. Just a reminder of that, okay? All right, so the first thing that this tells us to do is enter our equation. So I'm gonna go back to y equals, and I'm gonna clear out that equation that was there. And I'm now going to put in negative 0.25 x squared plus 5x. So that's what we want to put in as the y equals, and notice then it says enter the entire equation, which we did. Okay, now if we were creating the table, we would now do second table set, put those values in, the start and the change of table, and then we would do second table and it would give us the table. Okay, but now what we're going to do is we're going to learn how to show the graph. So now our second step, so we don't use the second button when we're graphing. We're going to go to the button that says window. Second gray button, window. Now, what we're going to enter is always an x minimum. So x values go on your horizontal axis. So we're putting in the minimum value that we want it to start to a maximum value that we want it to end. And we're going to do 0, which would be in the corner. And we're going to do 25, which would be somewhere over here. So mine already has that in there, but you can put in 0, down arrow, and then put in 25. So every problem, that minimum and maximum will change. All right. Then our third step is now we're going to push this button that says zoom. And you're going to get all of these options. Now, the option we want is 0. I'm going to scroll down and show you where it is and what it says. But eventually all you have to do is hit zoom. And then even though the number 0 is not showing, you can just push 0 and go straight to it. But I'm going to arrow down to 0 and it's called zoom fit. So I'm going to put in 0 and then I'm going to pause and my calculator will graph for me. And so if I was going to be sketching this, it doesn't start right in the corner. It goes up, it goes through 25 and goes through it. So it would look something like that. Okay, so is there anybody that did not get that? Are you getting an error message?
Yeah.
Okay, I have a student in 930 that has the same calculator. I'll try a reset. I did with him and we could never get to it. I Googled something when I went back to my office. I don't know the solution
Okay.
as of right now because this calculator is different. But if you want, well, I'm gonna do it. I can't, it did not fix it for his. So let it reset and try again,
Okay.
but I'm still trying to troubleshoot his too. I have no idea why it's not working. Yeah, that's right. Anybody else?
Keeps going back to.
Hey,
Here.
Did you push enter? Okay, so you're gonna do this as well, because you keep getting an error. I want you to do second and the plus button. Well, first we do this now. Okay, second and plus. That's fine. Do second plus
This
And then I
works.
want you to put in 7 for reset. And then, I'm gonna right arrow over to all. And then hit
There you go.
enter. And then I'm
I
gonna
think
put
you might have
in
typed something in.
2,
wrong.
where it says
Okay,
reset.
Thank you.
After it goes through all that, try it again and see if it comes. You did times 5x and it's supposed to be plus.
That's a. that's a-
So after it does, try it again. I don't know. Yeah, you're gonna have to go on. Did you guys, are you still, it worked? Did yours work? Okay, let me know. I know, did you figure?
Yeah,
Oh, please show me the solution.
yeah. I think you might have typed something wrong in. So it was either you typed something wrong in the Windows
Well,
or like something in the line, because I did the exact same thing and it worked.
okay, so let me see yours. Here's the problem. That is so weird because did you retype something?
No, I did. I retyped everything that I entered to it. So I did one.
Okay, but I made sure of all these things on my prior students and it didn't work. Okay, we'll try again. I'm glad to know. So you didn't happen to recognize what was possibly typed in wrong? Okay.
It might have just been the window.
I don't know, so I'm glad to know it worked on that one, because I've got to get Michael's going. Okay, anybody else? Okay, now there is another button that we're also gonna look at on your kind of your cheat sheet. It is this down here where it says trace. Okay, so, which is given right here as well. Okay, he's right next door, so I'm hoping I can figure it out on his. Okay, so what I want you to do now is I want you to hit the button up here that says trace. And now some information is going to show up on your screen. If you'll notice the very top, it has the equation. Down here, it has an X value, which is your variable, and a Y value, which is your function. Now, if you'll look up there by your equation, and I'm going to right arrow, there's this cursor that you can move. And when I move it, these values change because this cursor, this is giving you the ordered pair at that point. So like if I leave my cursor there, that means on the x-axis, it is going over 15.16, and then it's going up 18.34. And so you can move this cursor, and as you move it, your X and your Y will change as well. But it's giving you the ordered pair of that particular point, because that is something that we'll look at as well. Okay, all right, so any questions before we get into now? Yes, ma'am.
My calculation number.
Okay, we'll have to look at it after class, so try to piggyback off of that, so. All right, okay. We're gonna clear out that equation. And we're gonna look at number 1. All right, Waterton Lakes National Park of Canada, where the Great Plains dramatically meet the Rocky Mountains in Alberta, has a migratory bison herd that spends falls and winters in the park. The herd is currently managed and so kept small. However, if it were unmanaged and allowed to grow, then the number N of bison in the herd could be estimated by the logistic formula here. And it tells us that T is the number of years since the beginning of 2002. That is the first year the herd is unmanaged. Okay, so we're gonna go ahead and define our function and our variable. What letter are they using for the function?
Bisons. Oh, sorry.
N,
And-
which is number of bison. Or population of bison, either one. And then variable is given to me down here. Don't forget to include the beginning of it. So T, this is years since 2002. All right, so if I said T equals 0, what year am I referring to? 2002. So if I said T equals 5, what year is it? 2007. Okay, so just a reminder of that. All right, so we're going to enter this into our equation. We know the function is our y and the variable. So wherever a T is, you're going to put an X. All right, and don't forget, we've got to get to a fraction, which is alpha y equal 1. All right. Okay, so I'm gonna look at part A. It says make a graph. All right, so I'm gonna draw my graph. We've already done the y equals, that was step 1. Okay, before I go to my next step, when I grade your graph, you have to label your axes. You can't leave them blank, okay? So what goes on the vertical axis? That's your function, which is,
Wow.
it is y, but what is that for this problem? N. In your calculator, it's y, but for this problem, it's n, which is number of bison or population of bison. And then the horizontal axis, what is my variable in this problem?
Number U. T.
P, and then it would be years since 2002. If you don't label your X and Y axis, I will count off. Okay? All right. Now, it goes on to say that this graph wants us to cover the next 30 years of the herd's existence. Okay, so this is what is helping us set our window. So push the button that says window. Now, what is the 30? Is that going to be your minimum or your maximum? That's your maximum. So where are we going to start at? 0. So do 0 and 30. Okay. All right, now the last one is your zoom. Now you can hit zoom and then scroll down, or you can just hit zoom and then we know it's number 0, so just go down and push 0. Did you get the minimum and maximum in? Okay, so then you just hit zoom 0. And it should look like this. So I know that my x-axis, which is the variable t, goes from 0 to 30. So you need to give those numbers. And then I'm going to sketch it best I can. And it looks something like that. Did you get it? You don't have the variable x in your equation. So when you're entering, you put in -0.23
Oh, okay.
Because it didn't have anything to put in.
Okay.
Yeah,
And then
Did it not work that time?
because.
Oh, if it, I mean, do it the best you can, okay? I mean, if it's extremely awful, so like. He's like, I get it, alright, but if you give me something like that, no, I won't take that. If you give me something like that, no, I won't, it's gotta at least be close, so I'll have some grace because I'm not an artiste either, so. Did that work, Erica? Okay. All right, so now part B and C, it's gonna get into where you're not doing any calculator. It just wants to make sure you have an understanding of the question being asked, okay? So it says, if you are asked for how many bison will be in the herd at the beginning of 2002, are you being given the variable or the function? Okay, so I'm gonna look at this. It's asking me for number of bison. Would you agree with that? The wording. Okay, so it asks me to find the number of bison. So then I want to determine, okay, what did they give me? Well, I look up here and they gave me, it states at the beginning of 2002. So are they giving me a value of number of bison, or are they giving me years since 2002? So did they give me the function or the variable value? Variable value. So we are given the variable value. That's all that's asking. Now, I am going to ask you, when it states at the beginning of 2002, and I already asked this, they're telling me that T is equal to what? 0, that's your initial value. Okay, but that's all it wanted to know, that you had an understanding that you were given the variable value. So don't make more out of that than it is, okay? All right, part C, so we still have the same equation. If you are asked when the number of bison, political season is upon us, isn't it? If you are asked when the number of bison first exceed 300, are you being given the variable or the function? Okay, so when I look at this, I'm going to go, what are they asking me? They're asking me when. And they are giving me exceed 300 bison. So this is what they gave me. So if you go back to our definition of function and variable, what did they give us? Function or variable? Function, because if I go back here, your function is the number of bison. When is time, right? So we were given the function value. Okay. How many bison will there eventually be in the herd? What are they asking us for? The limiting value. All right, we now actually have two places that we can do this. I'm going to turn it back on and get back to my graph. Okay. So we can tell that this is decreasing, right? And so eventually it gives us a limiting value. So one way to see the limiting value is to use trace. And then just keep cursoring over and over and over and over until you're looking for this number to be your limited value. I think it's easier to see the limiting value off of the table. Okay, so I want to look at this in the table, so I'm going to do this in table. So first we have to do table set. So that's second table set. Now, so think about this. Do I want to start at 0 in table set if I'm trying to find this up here? Couldn't I start even maybe at 25? So let's start at 25 and then let's go by 5s. So I'm gonna do table start at 25 and then change the table in 5 and then we do second table. And now I'm looking over here. And I am just going to scroll, keep scrolling down, and bam, what do we hit? I hit 315 at year 60, right? Okay, so how many bison will there eventually be? What would you tell me? 315 bison. Okay, so this is all it asked. So if that's all it asked, that's all you have to give me. But good job. When did this occur? T equals what? 60. So that would be 60 years since 2002. 2002 plus 60. So 2062 is the year that this occurred. So that, although this one did not ask that, that is a very legitimate question that could be asked. WebAssign on a quiz or in a test, okay? Now, y'all, my graph is still there. If I checked my window, it's still the same. I can go to zoom 0 and it's still there. So even though I went and messed around with the table, I can still get back to my graph. Okay, so you don't have to re-enter everything. I did check to make sure it was all still the right minimum and maximum and all that. Okay, all right, so when is the graph of your function n of t concave up? Okay, so when I look at this, this is where your trace is helpful. Hey, come here. Pause. I have 2 guys that have the same calculator. And so they were able to get it to work. So let him look at it. He was my stud that got it taken care of. In the black shirt. Yeah. Go back to that negative 0.251 and see if you guys can get it to work. I don't know what I was missing. So, all right. So, what does it say? Okay, concave up. So if you'll notice in this graph, we have concave up.
So you press
And we have concave down.
I understand.
Is it working?
You use this instead of this. So now.
See, now I'm really curious, just in case somebody else has this problem.
You press up. Yeah, you press this one. So and then.
Did he push minus instead of negative?
Yeah.
So one thing I didn't check.
There you go. Yeah, it's
So-
a difference in the.
Okay, I could say something to him that would be why that occurred, but I'm not gonna say that in front of everybody. It's something between Michael and I, him knowing too, so. Thank you. Just know that anytime you put in a negative, you don't use the minus button.
When
Did you happen to do that? I don't know. Okay, we'll check it out.
whenever there's an error, there's it gives you like 2 options. There's either like there's either number 1, go ahead, or there's number 2, it's called Gato, which means it goes to the thing that's
It's messed up.
Yeah.
Okay, that's good to know.
Yeah.
Okay, thank you.
You're welcome.
I've been racking my brain trying to help him, and that's the one thing that I didn't check. Okay, so what we're talking about, this has concavity of concave up. And it starts at 0, and then at some point here, it goes concave down. What do we call that point?
The
Inflection point, okay? So I'm going to hit the trace button, and there's gonna be a cursor that shows up. Now, this is where we have some flexibility on our, what you see as the inflection point, but hopefully you would agree with me that it's probably down further than that. All right, so I'm gonna left arrow, and I think the inflection point is probably somewhere about right there. Okay? So when we're looking at the graph, this is your x-axis. It starts in the corner. What is your x value in the corner? 0. So it goes from 0 to this cursor. Well, there's the x value. You don't have to put in that full number. I'm just going to say 0 to 13. Okay. So it says, when is it concave up? It is concave up from 0 to 13. And this was years since 2002. Because that's our variable. Okay. Now, we're going to go ahead and say what that means in terms of the growth of the bison. So all we're doing is looking at the first part of the graph from here to here. So what is this graph doing? It is at an increasing rate. But instead of saying the graph is doing that, what is our function? The number of bison or the bison population. So the number of bison is, and you told me it was increasing at an increasing rate. All right, so then it wants to know when it's concave down. So if I ended at 13 on concave up, that's where I'm going to start on concave down. And how far does this graph go? To 30. So we're going to say from 13 to 30. Now, if you had given me 0 to 12 or 0 to 14, that's fine, as long as whatever number you put here, that's what your starting is on your next concavity. So now we're looking at this part of the graph. So the bison is increasing at a decreasing rate. Okay. And that goes back to things we did on the last unit as well. Now, this says estimate the inflection point. Well, based upon how we answered this and where I put the cursor on my calculator, what did we estimate the inflection point to be? Right. Now, this is when our variable x equals 13. But in purposes of our specific problem, I won't say x equals 13. I'll say t equals 13. 13 years since 2002. So what year is that?
2015.
Okay. So remember, I don't want you to, in an explanation, say 13 years since 2002. We don't do it that way. Okay. All right. Now it does say to explain. Okay. What happens at the inflection point? So what's going on with the bison at that inflection point?
It's in rapidly.
Increasing or growing most rapidly, the fastest, you can use any of that wording. So I would say the number of bison is, and then you could say increasing, or you could say growing, whichever way you want to do it. The most rapid or the fastest, anything that represents that. And then we found it to be in the year 2015. Okay. All right. On this next example, we're going to recognize this equation. All right. The growth G of a population over a week is a function of the population size in at the beginning of the week. So if both N and G are measured in thousands of animals, so like 1, that means 1,000. 10.2 means 10.2 thousand, okay? The formula is given, and here's our formula. All right, so what letter is representative of my function? And what does G represent?
Thousands of animals.
Growth of population, and that is in thousands, but it represents growth of population. I'm going to do in thousands. That's how I'm going to abbreviate that. So we know in our calculator, this is your Y. And then our variable then would be N, and what is N? Population size, yeah. So population size, and yes, at beginning of week. And again, this is in thousands. All right, so this is going to ask me to make that graph. So I'm going to go ahead and label my X and Y axis. The Y axis is always your function. So I would say G. This is your growth of population. And this is in thousands. And then my variable is N, which is population size. And this is also in thousands. Okay. So go back to your calculator and do Y equals. Clear out the equation we just did. Okay, now you're going to try it again this time. Try it again this time. And I don't know what you did last time, but don't hit negative. This is a minus sign.
Yeah.
This is your negative button. See if that fixes it. Okay. So it's negative 0.25 x squared plus 5x. So that's our Y equal. All right, then we're going to go into window. And we need an X minimum and an X maximum. So this is where, when I read this, make a graph of the function G versus the variable N, include values up to 25,000 animals. So what are we going to start at? 0 and go to
25,000.
25, and that is 1,000. So I'm gonna go window, 0 is there, I'm gonna change this to 25. And then what is the last step? Zoom, and then what number are we gonna zoom? 0. So we're gonna do zoom 0. Keeping my fingers crossed. And then I want you to draw that on your page. Did it work?
Yeah.
Oh, yes.
I have put the 0 for this one.
Oh, that'll mess it up too. Yep.
You know,
I'm just glad it worked. It looks something like this. Okay. That's what you got, Erica?
Does it have to cross 25?
Oh my God, I did something wrong. somewhere.
Mine's supposed to be 25. That's where mine. Should be 5x, not 2x. All right. Use functional notation to express the growth over a week if the population at the beginning is, so population at the beginning is 4,000 animals. And so we're doing functional notation. Okay, what did they give us right here?
The,
Right? Population at the beginning. So this is your population size at the beginning. So they're giving us that n equals what? 4, because that's 4,000, right? So how would I write that in functional notation?
Yeah.
D at 4. Now, I want you to remember that if you have a number inside the parentheses, this is always your variable. Therefore, what were we given? We were given the variable value. And that's the second part of what that is asking you. All right. If you're asked to calculate V at 24, are you being given the variable or the function? Again, this is inside the parentheses, which is always the variable. So we're given the variable value again. What does that 24 mean? 24 what? 1,000 animals. It says if I asked you to calculate. So it didn't ask me to go ahead and calculate it. So that's all it's asking for. All right. For what values of n is the function g increasing? Okay, so look up here. If I start, what is my graph or my function doing? Increasing, and then it hits a what? Not an inflection point. That has to do with top of the hill is your maximum. And then what happens? It decreases, right? So this is only asking us for the values of n, which is my variable, right? This is your variable x. We called it n, and it only wants to know when it's increasing. So it's only asking us about this part of our function, and then it hits this point right here, which is your maximum. Okay? So we know that it's increasing from, it starts at 0 to, and now we've got to figure out what this number would be. Whoops, yeah, okay. All right, so this is where you're going to use your trace button. I wrote trace here. So I'm gonna push the button that says trace when my calculator is on. All right, so now we want to find the top of the hill. So we want to find where the function has the largest number. Here's my function number. Well, if I go to the left, that number is going to get smaller and smaller. So sorry, that's to the right. When I go to the right, that number gets smaller and smaller. So I know I need to move my cursor to the left, and I'm going to watch this number until I hit the biggest number. So I'm at 23.4, it's still growing, 23.7, now it's at 24, 24.2, it's still getting bigger, 24.4, it's getting bigger, 24.6, it's still getting bigger, 24.7 is bigger, 24.8, all right, 24.9. Okay, now I have 24.9 again. This was 9.6. 9.9 is bigger than that. So I'm going to go one more to the left. 9.93, it's now going smaller again, right? So I'm going to go back to the point 9.97, and I know my cursor is at the top of the hill, which is my maximum. So what we have found is that if I gave this value right here, that is 24.997. And what I want to know is the X value. So I'm going to look at this X, which is 10.106. So I'll just go ahead and put 10.11. So 10.11 is my N. So we know it's increasing from 0 to 10.11 thousand animals. So this, in particularly, this value is what we had to find on our calculator. Okay. Is this graph concave up or concave down?
Down.
It's concave down. All right, so then it says explain in practical terms. All right, well, what we're explaining is what the graph is doing from 0 to 10.11. Right, so what we're explaining is this. So the growth of the population is increasing at a decreasing rate. So the growth population of animals is, you told me it's increasing at a decreasing rate. Okay. Oh, period. Okay, so